Lesson 13, dividing decimals by decimals. So we're going to divide decimals by decimals. All right. Today I can explain how multiplying dividend and divisor by the same power of 10 can help me find a quotient of two decimals. And two, I can find the quotient of two decimals. So make sure you have today's date, your ICANs and page number, and you are ready to move on. All right, let's do a little quick warm up here. So would the quotient for this be more than one or less than one? It's going to be less than one, right? Because you have a number, dividend, getting divided by a divisor that's larger. So you're going to make something that is less than one whole. And if we think about that, think about what that would actually be, we could find out and think about if any of these would be the same. Poof, it's done. So it makes 72 hundredths. So what about these? Well, here B would work because it is both of those are multiplied by 10, so it's 10 times greater, so it works in both cases. What about here? Yeah, no. Here we're multiplying one by 10 and the other one by nothing. That doesn't work. Here this works because that in the original problem, the 5 and the 7 were both in the ones, and since both of those are in the hundred thousands, this one works too. Okay? So yeah, using this will really come into play today. All right, knowing this, let's talk about placing the decimal point in some quotients here. So I've got 3 divided by 12 and 1 8/10 divided by 4 thousandths. What are some different expressions for each of those? Well, here you're talking about 3 divided by 12. Oh, let me fix that. So you divide this one out, you end up with 25 hundredths. Well, anything that ends up, as long as you change the things the same way, like if you do 30 divided by 120, if you do 3 hundredths divided by 12 hundredths, the point is, and we could do hundreds of these, the point is that as long as these digits have been changed by the same power of 10, it doesn't matter. You can still make any of those change. You can change that decimal point wherever, but you're still going to end up with the same answer at the end. Let's look at the other one. So on this one, even though it is 1 8/10 divided by 4 thousandths, I went ahead and put them all as whole numbers. For me, it just makes more sense to make them both into whole numbers completely. But it still comes out the same. And I can even prove this by taking that 450, multiplying it by 1 8/10, and I should still end up getting that 4 thousandths. And oops, I actually need to multiply it by the 400 or the 4 thousandths, right? Because those two together should make the 1 8/10. Voila, it does prove it. Still comes out to be the same. You know, and we could have made these into like what, 18,000 divided by 40. I mean, there's a ton of ways that we could shift that decimal around, but again, it's about moving it in the same, by the same power of 10 on both parts of that division. All right, so let's talk about both a couple ways to make quotients with decimals. So in both of these, we have 48 and 78 hundredths divided by 9. In the one, we still have, we're really looking at just straight up dividing, right? Putting that decimal and just going through like always. Here, you know, the difference is that we've multiplied both of these by 100, giving us 900 here and the 4,878 over on the other side. But still, when you divide it out, you still get the same quotient. Why? Because we're still dividing the same digits into the same digits. The only difference is the value of those digits. And since both of these have changed with the same value, you're still going to get the same quotient in both cases. You can, there are some advantages to both ways of dividing them out. As far as I can think of, the advantage with leaving the decimal alone is that you end up getting, you're not using larger numbers, which can be a little bit more difficult. Whereas here, one of the advantages is that you don't have to really think about that decimal piece until you get to it. And by the time you get to it, you've really gotten something, more manageable to use. It's really a preference thing when it comes to dividing by a whole number on those, okay? All right, let's practice some division with decimals. All right, so find the quotient on each of these using your preference. Okay, so the first one here, I think this one is not so bad. Oops. Three can go into the 10 3 times, giving you 9. Got one left over. 3 will go into the 16 5 times. Oops, backwards there. What in the reversals, Batman? So we end up getting 35 and 5/10. You could have, multiplied both those by 10 and did 1,065 divided by 30. Still going to get the same thing here. What about here? Now, I will say this, if you do not take the decimal out of the divisor, it gets a little tricky to make certain that you get the correct answer. Okay, and I'll show you why in just a second, because I'll prove it here with this. So 7 will go into 58. Let's see, 8 times? And that should be 4. Okay, so it should be 84. And we can prove that with the multiplication. If you take 84 times 7/10, you're going to see that. So 58 and 8/10 still makes sense there. Here's where it gets tricky when you're talking about those not moving that out. Millions of years ago when the dinosaurs ruled and Mr. Palin was in school, we were always taught that if you had a decimal in your divisor, you always had to take it out. And, I never really understood that until I got to working with this a little bit more. And I'm going to show you why. Because normally what you would think of is 7 would go into that 58 8 times, right? But that's not really what we're doing here. We have to think of this as 7/10 going into 5. How many times can 7/10 go into 5? It can go 8 times. Well, 8 times 7 is the 56. And then how many times can 7/10 go into 2, the whole number 2? It can go 4 times, and you have to bring down the 8, and then you get 28 here. Because the mistake that most of us would make, and that I would make too, is that I would think of it like so. 7 can go into 58 8 times and put my 56 here. But this isn't 7 whole. This is 7/10. And that's why we have to think of it as actually that this is 80. And that's why it has to be over there. And that's why having this like this can be difficult. And I almost always suggest to multiply at least by 10 to get this into a whole number value, because if you've got this as a whole number value, you're less likely to make this mistake here. Because if I divide it out, I'm still going to get the same digits. But if I multiply it back, the 8 and 4/10 times 7/10, I'm not going to end up with 58 and 8/10. I'm going to end up with 5 and 88/100, which is not the original number. The original number was 58 and 8/10. So, I'm not going to say that you can't do it this way, but boy, it is very easy to make a mistake that way. Which is why on this one, I'm going to go ahead and straight multiply it by 10 and get that decimal out of there. So that way I can try and be a little more accurate. Let's see, 2. Yep. Again, I can prove this is correct by multiplication. So, it's really a preference thing. I would say, you wouldn't necessarily need to do it on all of them, like especially ones that are whole numbers already. But boy, if it has a decimal to the right, I think almost always you're going to want to do that equivalent multiply by, something, some power of 10 to make that into a whole number. So, and I think, same sort of thing when you're thinking about one like this, where you've got 24 and 3/10 divided by 170 and 1/10, that, for most of you, you are probably going to want to multiply that decimal out of the divisor just because it's going to help with being more accurate. Like I said, you don't have to. I just personally, for me, you know, so the quotient here, the key with all of this is, if you think about it, this is 170 and 1/10. It's going to be some sort of decimal that's going to be here to solve it out, because we are dividing by something that's at least 10 times, almost 20 times larger. So to sum it up, we can divide decimals by decimals. When we make, making those decimals into whole numbers can help us. In this case, we have 18 and 4/10 divided by 2/10. Be the same as, 184 actually divided by 2. This wouldn't be the same as this, right? Because we've got different values here. So really, this should be, instead of this, it should be 184 divided by 2 if I multiply both of those by 10. Again, it's always that when you change it, that you always have to multiply the dividend and the divisor by the same power of 10. Like with this one, I'd have to multiply by 100 to make this, or 1,000 to make this into a 5 whole number, right? Because it's in the thousands. Same thing here. If you do just one and the other, you can get the digits, but you're not going to get the correct values. So even if you do something like this, where you jump up the place value of one and not the other, it's going to really throw off where your place value is. And I just think that that's not efficient. Anyway, a shade long today. Thanks for hanging in. Have a great one.